We're going to identify the real number sets, and it's important that we can distinguish and identify what number and what set it belongs to in order to better understand how the different types of numbers work. Our first type of number is what we call the natural numbers, and typically it's made by just a capital N. I'm starting this out like a bullseye, so if you want to think of it that way, I think it'll help to clarify where these number groups go. The natural numbers are the numbers that we typically call our counting numbers. So the numbers that you see are the numbers 1, 2, 3, and so forth and so on as we continue on. Notice the brackets that I've put around are the squiggly brackets is what I call them. These represent sets of numbers. These are not parentheses, but rather they're for set notation, which identify that this clearly is a set of numbers, and there's a huge amount of numbers in here, in fact an infinite number. The next type of numbers that we have just add one element to our natural numbers, and that is what we call the whole number set. Now I'm trying to change colors for you on this so you can really see what the distinction is between these. Our whole numbers look like this. First of all, written just as it would be spelled, the whole numbers. But the only number that's added to our set of natural numbers is the number 0. The rest of the numbers are in there. And I'm color coding them like this for you so that you can see here are the natural numbers. Are the natural numbers a part of the whole numbers? And the answer is yes, they are. They're right here. Here's that same group of numbers. So all natural numbers are also whole numbers. Are all of the whole numbers natural numbers? And the answer is no, because the element 0 is not in the natural number set. So when you think of it from a numbers bullseye standpoint, all the numbers on the inner circle can move to the outer circle, but not all of the numbers in the outer circle can come back inside. Our next set of numbers is what we call the integers. And typically you can use two letters, and it depends upon which text we're using. Some texts will use a capital I to represent the integers. Others will use a capital Z to represent the integers. And it's just a distinguishing element or letter that they use. So I'm going to draw my numbers bullseye around those. What do the integers look like? Our integers are typically the numbers that you would put on a number line. So when I talk about the integers, it's the numbers. If I were to ask you to draw a number line, you would probably start your number line at something like -3, -2, -1. But now at this point, we'd also have the number 0 on our number line. And then we have our natural numbers, 1, 2, 3, and so forth. So as you can see when we look at this, are all of the natural numbers integers? Yes. Are all of the whole numbers integers? Yes. But are all of the integers whole numbers? No, they're not. Some of them are, but not all of them. So again, trying to distinguish the idea that natural numbers, the inner circle, can move to the next circle out and continue on its way out, but not all of the numbers in the outer circles can work their way back in. Our next set of numbers is what we call the rational numbers, and typically we use a capital Q to represent the rational numbers. And our rational numbers, so that set would come right outside. Whoops, sorry about my circle. Would come outside. The rational numbers, we use capital Q to represent them, are all numbers that you can write as fraction. So our rational numbers, easiest way to describe them, is anything you can write as a fraction. So, can I write the number -3 as a fraction? Sure, -3/1. How about the number 7? Yes, as 14/2 or 28/2, or 28/4, sorry. So all those would be considered rational numbers. Then we have a small group of numbers, and I put them as an isolated group. Draw them out here. They're what we call our irrational numbers, and those are the numbers that cannot be written as fractions. Some of the more common ones that you know of for irrational numbers would be numbers like pi. Would be an irrational number. You can't write pi as a fraction. It's a non-ending, non-repeating number, decimal. A number like the square root of 5 would be considered an irrational number, and so forth. Those are ones that they are non-ending, non-repeating fractions or decimals, so cannot be written as a fraction. Okay? And then finally, what covers all of these numbers is what we call the real numbers. And I always put a double bar on my real numbers so you can see that's what we're dealing with. So the real numbers are everybody. So all the numbers that you look at will always be called real numbers. So our real numbers are, the easiest way to describe it, it's your rational numbers, your fractions, union combined with your irrational numbers. So notice in this case, is a natural number a real number? Yes, it is, because it can go all the way out. Is a whole number a real number? Yes, because it can go all the way out. Are all of the real numbers natural numbers? No. Some of them are, but not all of them. So you can come in with some, but you can go out with everybody. That's your real number sets.